In this lesson, we're going to solve some basic trig problems. So let's start with a basic trig problem. We'll probably require the use of a right triangle. Oops, having a little difficulty there. We'll call this vertex A, which means the hypotenuse here is going to be of length A, and we'll call that, for the sake of argument, 7, because I'm just making these numbers up anyway. If this vertex is B, we'll call this side B, little b, specifically 4. So if we decide to call this angle C, and I want to find this angle, since B is also the adjacent to C, then knowing that I have the adjacent hypotenuse makes sense that I would use a cosine function of angle C, and that would equal 4/7. But because I already have the ratio down here being 4/7, that's really not a good way to end. I would actually prefer that this would be what I input in. So we should put a ratio of 4/7 in. That's 4/7. Having a little technical difficulty here. We throw that into a cosine inverse function, and that will give us the one angle out that we're looking for. So I will take my calculator, which you can't see. I am going to type into the calculator a cosine inverse of 4/7. Because it is a triangle, it would probably make most sense to be in degree mode. So as I type into my calculator, I type in cosine inverse. I'm typing in 4 divided by 7. I hit parentheses. I've checked my mode. It says degree. I hit enter. And what comes back is that the angle C happens to equal 55.15 degrees. And there you go. Just like that, we have a inverse cosine in action. So let's try a new problem. We're going to just erase everything on the screen. Here we go. Let's draw another problem. Maybe this time it'll involve a ladder going up a wall. This time let's make this a 20-foot ladder. And I know that I don't have to actually go up very far, but I still want to clean this window out, okay? And maybe this window happens to be 6 feet off the ground. So I want to know what my angle of elevation is. Notice how we're getting the phrase angle of elevation right there. So that would mean it's this angle. And since this time my 6 happens to be my opposite and my 20-foot ladder is still my hypotenuse, because we like to think that the building's at a right angle, then that would make more sense that I would have, let's say, sine of my angle, we'll call it theta, would be 6/220, which is the same, by the way, if the ratio was 3/10. So it would make sense to solve this problem. I would write sine inverse of 3/10. On the calculator, I'm typing in sine inverse. I'm going in my parentheses 3 divided by 10. I hit enter. And in this case, the angle that comes back for theta happens to be 17.46 degrees. So it's not a very steep angle of elevation in this particular problem. Let's look at another example completely. And this time, let's talk about a wheelchair ramp, because we've had that discussion before. I know that I need, let's say, to go up 3 feet, but the most I could possibly go out is 30 feet horizontally. And so how steep would this ramp have to be? We know that from prior discussions that if you were a new construction and for especially a building for business, they would not want this to be more than a 1:12 ratio, and this is a 1:10. So this is going to be steeper than we want. But again, this is not the adjacent. This is the opposite. This is the adjacent. And because I have the opposite and the adjacent, I would realize that the tangent of 3 is to 30, which would be the same as if I had gone only 1 foot for every 10 feet like I had previously discussed. I type into my calculator tangent inverse 1 divided by 10. I hit enter, and it seems that It's not majorly steep, but it is steeper than the 5 degrees that we were talking about. It's 5.7, more specifically 5.71 degrees. So there you go. 3 problems on how to use inverse trig functions with right triangles. Our next problem is actually goes back to something very simple. I have what is called, and we're going to stop there.